Chapter 8 starts with some new vocabulary terms, relations, and functions. The first term we're going to talk about is going to be relations or relationships. We're going to talk about that with this table about alligators. Now, many times you see such data when you're doing science, and you would see it on a graph. So we're going to look at what the relationship is between the age of an alligator and the length in inches for that alligator. So you'll notice that on the chart we have an X and a Y, because the X would be the x-axis or the horizontal axis, and the Y would be the vertical axis. So as we would plot on the X how many years old the alligator is, then we would rise up to match the Y-axis showing the length of that alligator. So you can represent relationships between the age and the length using ordered pairs X and Y. So the ordered pair form a relationship. A relation is a pairing of numbers in one set called the domain with a number in another set called the range. So each number in the domain is an input. So the input would be, as we were looking at each one of the alligator's ages, and each number in the range is the output. So the output would be the length in inches that that alligator is. So you can see we have the first pair that we talked about here, 2, 32. So that would be 2 for the X and 32 for the Y. And you can see how these match up. 459, 565, 569, and 796. So this time we're going to do a couple of practices with identifying the domain and the range. Again, as I said on the last example, the domain is going to be the X. Let me put that in a different color so it stands out more. The X, and the range is going to be your Y. My X doesn't, there we go. Okay, so in letter A, the table at the top of this screen, we're going to identify the domain and the range of the relationship represented by this table. So I would have the domain would be 2, 4, 5, and 7. Now I do not have to repeat the 5 for my domain because I have, I can just list it one time. But notice that the domain is listed in numerical order. Then I'm going to list my range, which is the Y, and I have 32, 59, 65, 69, and 96. So you'll notice I only have 4 domains, but I have 5 ranges in that top table. In the next table, again, the table is organized in numerical order, and I have all different domains, so I will list each one of them, 1, 2, 3, 4, 5. And then if I look at my length, that is my range or my y-axis, and I would list those in numerical order as well. So you can see why they call this a relation, because we can look to see, does the age have anything to do with the length of the alligator? And as you can see in both of the charts, as the alligator ages, the length of the alligator gets longer. Okay, so this time we have that the domain and range are listed as coordinate pairs or coordinate point. So my x's this time are going to be the first, whoops, go back to my pen, the first, and my y is going to be the next. So my domains in each one of those ordered pairs would be 0, 2, 3, and 5. Lost my arrow there. Okay, then my range would then be the y coordinate point. And you notice that there is a repeat there. We have 2 4s. There is a 4 in this y and a 4 in this y. So I don't have to say them twice. And I do again put those in numerical order. So doing the next one here, you're going to see that we have some negatives. So remember how those work with putting them in numerical order. And my domain is going to be -3, -1, 6. Looking at just the x's again, just the first numbers. And then my range is going to be my y's. And so I'm just looking at the second part of that coordinate point. Okay, I think that's probably enough of that. Now we're going to talk about representing those relations. We can represent them using ordered pairs as we have been, or we can represent them on a table. You can also use a graph or a mapping diagram. So in a graph, we're going to go ahead and again, we're talking about the x and the y coordinate point. So the x is how we move left or right, and the y is how we move up or down. So you can see the first point, 1, 3. I'm going to move to the right 1 and up 3, and there, oops, better change to a different color. I want you to see that. There is point 1, 3. Next, -3, 4, so I move on the x-axis again. And see where they've written x and y for you. Move to the left 3, but it's a +4, so I move up 4. 0, 2 means I wouldn't move anywhere left or right, but I would move up 2. There's my 0, 2. And the last one, 1, -3, I'd move to the right 1, but I'm going to move down 3. There's my 1, -3. You can also use a mapping diagram. When you're using a mapping diagram, you are to use arrows from the inputs to the outputs. This will be important in the next part that we learn about what makes a relation something different or a function. So if I do that same thing here, I'm going to use an arrow. If I can get my cloned arrows here. Let's use my finger. Oh, still not helping me. All right. I'm going to, my first set was 1, and that is going to 3. My next arrow is -3, and that is going to the output 4. The next one listed here is 0, and that is going to 2. Whoops, moved my wrong one. And my last coordinate point or relation is 1, and it is going to a -3. Now we're going to talk about this in the very next screen. You'll notice that there are two outputs for 1 here. 1 went to -3, but 1 also went to 3. We have that right here where when we moved over 1, we went to this point here, 3, but we also went to this point here, -3. We'll see what that means on our next screen. So, we talked about at the beginning relations and functions. Function is a relation that only has, for each input, there is exactly one output. So, in example 3, we're going to talk about, is this relation a function? So, is how the x goes with the y a function? So, again, we have listed the relation of the first slide consisting of those ordered pairs for the age and the length of the 5 different alligators. On this one, you can see we had alligators that were 2 years old, 4 years old, 5 years old, and 7 years old. The problem is we had 2 different alligators that were 5 years old, but they did not have exactly the same length. One was 65 inches, the other was 69 inches. That makes this only a relation and not a function. A function means it is a work that we could always put it in and predict the exact answer. The relation in the next slide, we again had alligators. They were 1, 2, 3, 4, and 5 years old. So we had different ages again. But for each one of those ages, we had a different output, a different y. There was never the same input with 2 different outputs. There were 5 different inputs followed by 5 different outputs. Now there are some easier ways to test that. The easiest way is the vertical line test. So vertical line, remember vertical, if you make your finger with your you make a finger, if you make an arrow with your fingers, you will see, if you make a V with your fingers, sorry, it will make an arrow going up and down. So this is our vertical line test. To check a relation after it has been graphed, you can use the vertical line test. What this means is that you're going to take a vertical line, and you can do this just with your hand if you wanted to, and you're going to go over your graph. As you go over, the vertical line should only hit 1 point if it is truly a function. Here it hits 2 points, so the answer for this one is going to be that this is not a function, it is only a relation. This is a false statement here. Okay, as we move on, we'll do a couple more of these. There's my vertical line again. I'm going to go across and hitting 1 point, only 1 point, only 1 point. That means that this here is truly, I'm going to give you a better color here, this truly is a function. This relation is a function. Now, let's check it with an input-output or a mapping diagram. So, for the mapping diagram, remember I need to have arrows. So let's look at this. We have 2, -2, 3. So -2 is going to go to 3. Okay, our next coordinate point is 1, 3. I'm just reading the coordinate points from left to right now. The next coordinate point is 2, 1. The next one, I'll go with 3, 0. And the next one is 4, 3. It wants to give me one more arrow. Now, I just made a mapping diagram for this exact graph. And in this graph, I said that this was truly a function. You will notice here that we have several answers that come to the output of 3. Okay, we have in fact three different ones that come to the output of 3. However, for each input, they are all going to a different output. So that means that this is a function. It would not be a function if one input would go to 2 different outputs. In problem number 10, let's do the input-output or the mapping diagram first. And so, get my right tool here. If I look for -1, here's -1. -1 is going to 2. So I'm going to go ahead and match them up. 1 here goes to 2, but it also goes to, it also goes to 3. 2 goes to 0. And then 3 goes to 4. So if I'm looking at just the mapping diagram, I notice that my input 1 is going to 2 separate outputs, 2 and 3. Therefore, each input has to have 1 output, so I'm going to say that this is not a function. Let's go ahead and check it this time with the vertical line test. My vertical line going across the graphed points. I'm only going through 1. I'm only going through 1. When I get to here, I'm going through 2 separate ones. So this is not a function. This is false. It's a relation. It is not a function. And that concludes lesson 8.1. Do 2